Thank you for being here today. So my name is Jonathan, and I'm with Canonical. And at the same time, today we're talking about how we're accelerating open innovation with SpacemiT. And with me here today, we also have Yanbang, who's the co-founder of SpacemiT, who came all the way from China to join us here in London to talk about what they've done with the K3 platform and how they're supporting the open source ecosystem. As well as that, we also have Andy Moore, who's coming from RISC V International, joining us at the very last part, and there's going to be a surprise at the very last part of the talk. So please stay with us. So I wanted to start off by looking at what we've done in the RISC V space. So when you look at the trajectory of open source, it thrives on one core principle, which is open collaboration. So this is exactly what drew us to RISC V. So our journey started back in early 2021, and we saw RISC V not as a new architecture, but as a future of open hardware. We dove head in, releasing the first Ubuntu image on QEMU, which is an emulator, and worked alongside other partners in the space, such as the Sci-Fi Hi-Fi Unleashed and Unmatched boards running on 2004. And also, one of the earliest, proudest moments is our collaborative demo that we've done with the Allwinner Technology board here on the robotic arm, and which is powered by the Xuantie C906 processor. So from our day one, our goal has been to bridge the gap between cutting open edge silicon and stable open source software. Since those early days, our investment hasn't wavered. In fact, it accelerated. So as we noted in our retrospective that we published back in 2020, in February of 2026, we thought 2025 was a year of RISC V readiness. It was a year where we decided to raise the bar. We made the strategic choice to start supporting RVA23 even before commercial hardware is available. Why? Because to drive RISC V into enterprise mainstream, we need to reduce or remove fragmentation. And our pivot to RVA23 is a commitment to architectural excellence. It provides developers with unified high-performance feature set optimized for the modern computing workloads. And Yanbang today will talk a little bit about what his company has done on this aspect. And with our recent work in Ubuntu 25.10, we are actively closing the gap between silicon innovation and software readiness. And we want to ensure the moment that new silicon drops, developers have immediate access to the latest and greatest hardware and software. But driving the future doesn't always mean abandoning the past. So we know the community still heavily relies on existing platforms. That's why we're balancing our push into RVA23 with our commitment to legacy hardware. So this is being supported by our older LTS on the 2404 for any legacy platforms. And for at the end of 2025, we've also done a lot of work with our different silicon partners, and we also have multiple RISC V platforms available. And we also started the RISC V Cookbook program, which was a great success, and actually that was what drove SpacemiT to work with us here. And we can talk a little bit more about this later on. So where are we now, right, for 2604? So if 2025 was about readiness, 2026 is a year of scaling. This is where we reached an inflection point where new hardware is hitting the market, and the RISC V platforms are moving rapidly out of the R&D labs and into commercial products. So stretching from all the way from the clouds to the edges, and we are prepared to enable our partners to leverage the absolute best of open source. To make this happen, we need to focus on empowering developers. So we are working with our silicon partners to ensure the latest and greatest silicon platforms are available on Ubuntu. And we're continuing to deepen our relationship with these different board vendors and hardware vendors that are making these silicon platforms available to our developers. Our goal is simple. We want to make sure the Ubuntu is the go-to platform that makes development amazing experience for our developers. As we look further into the future, our roadmap is guided by 3 strategic commitments. The first is product parity, to close the product parity gap. We need to ensure that what is our product portfolio is running robustly, and seamlessly, just like any other architecture, like the x86 or ARM. Second is enabling commercial use cases. We're seeing an incredible shift from our silicon partners, not just innovating the low power domain, they're also aggressively moving into the enterprise server space. So at the same time, we're seeing RISC V is becoming used in other verticals like robotics and AI computers. And a great example of that is when SpacemiT participated in the first humanoid marathon hosted in Beijing, where we probably saw some news article where you saw some humanoid robots racing each other in the streets of Beijing. And finally, keeping community at its core. So community remains our anchor, and we're committed to make sure that we are providing support to our community worldwide. To see exactly what this looks like in the real world, we don't have to look very far back. So in the past, in February, we worked with SpacemiT to validate early builds of 2604 running directly on SpacemiT's newest K3 processor. And we published this on our website back in February. And the response from the tech world was overwhelmingly enthusiastic. Why? Because it validates that our commitment to RVA23 profile was right. We had, by successfully running 2604 on K3, by successfully running 2604 on K3s ahead of launch, the industry saw exactly what readiness means. The tech media rightly highlighted that K3 was one of the first commercially ready chip to natively unlock the true power of RVA23 out of the box. And this validation proved the software baseline and our silicon innovation is a perfect match. And now I'd like to introduce Yanbang, SpacemiT's co-founder, to introduce his company and what the newest platform has for our developers.
Thanks, Jonathan. Hi, everyone. This is my honor to be here. This is my first time to London. I'm Yanbang from SpacemiT. Today, I will talk about RISC V and the SpacemiT. The first, we will talk about RVA27. RVA27 is a milestone for RISC V. The Ubuntu 2604 RVA23 towards the RISC V high performance era. The first, slavery is the fragmentation. The RVA23 defines standard foundation for the high performance computing. Enable software to write once, run everywhere. And the second, Ubuntu's new benchmark, Ubuntu 2604, use RVA23 is called benchmark. Enforce vector computing and security extension to unlock the full period of desktop and server workload. So the RVA23 is the milestone for RISC V high performance. This quick introduction of SpacemiT. What is SpacemiT? SpacemiT is a RISC V AI CPU chip company. What is AI CPU? Before, everyone used the general CPU for run software, run operation system. But for the new generation application, the application will use more AI performance. So the new CPU will include more powerful AI performance. So we want to use RISC V architecture to deliver CPU performance and AI performance. But for the software, you can see everything as CPU, general CPU and AI CPU. This is the core technology, computing technology from the core chip, software, and application. The main application is AI computing and AI robot. And we commit advance and research the RISC V and AI and treat and Thailand intelligence computing ecosystem. Enable application as AI-powered computing and AI robot. Maybe the AI-powered computing the general name is engine computing. This is a quick introduce of SpacemiT. This is our vision for RISC V ecosystem. SpacemiT wants to be the hardware foundation of RISC V open source software. We believe that the future of computing should be open. Our goal is to empower development with high performance, high intelligence, and user access application process, and empower millions of global Ubuntu development. This is a vision for the RISC V open source ecosystem. All the hardware is our delivery for the RISC V software ecosystem. This is our product roadmap. Our first generation AI CPU is K1. It is an entry-level AI CPU. It has 80 core, 4 core general CPU and 4 core AI CPU. Our second generation product is K3. This is AI performance. It is about 10 powerful performance, and the CPU performance is about 5 more power. The general CPU performance. Our next generation AI CPU is K7. The K7 will have more powerful CPU and more powerful AI performance. From first generation, the second generation, and the next generation, K1, K3, and K7. This is the K3 is the first RV23 platform run on Ubuntu 26.04. Fully support the RVA23 standard. Open a new chapter in the RISC V computing. This is the main spec of K3. The first is the CPU. It has an 80-core CPU. This is CPU's benchmark, and this is the AI performance. We can support LLM. The master is 20 billion and LLM. We support the mainstream model data format from LP16, BF16, LP8, int8, int4. Our next generation will support LP4. The AI performance will up to 60 TOPS, and the memory will support 32 GB. So you can storage the 6 billion LLM on this chip. This is the interface. We support PCIe, USB, all the mining, the SoC platform, And this is other computing, such as GPU and video encode and decode. And we support 4K display. This is the main spec of K3. It is a very mainstream process, application process, RISC V application process. This is Ubuntu 64.0 native support. SpacemiT development with Canonical. We deliver a native Ubuntu 60.04 experience with K3 platform. We developed through the cookbook program for the development ecosystem. Now the kernel schedule optimization release the performance for 80-core architecture. And RVA23 vector optimization for the database performance. For access to the Ubuntu reports, ready to use out of the box. This is the native support of RISC V for the Ubuntu 26.04. For SpacemiT, every generation chip and SDK release, we sync with the Ubuntu the version release. The first generation is K1 SDK, and our K3 SDK from the Ubuntu 23.10 and 24.4, 29.4 and 26.4. Now you can download the Ubuntu 26.04 for K3 is available. This is the link for K3 image. And other is about the K3 hardware spec and the spec. But K3 is development friendly. K3 is built for development. The first, we are the mainline first kernel enable. We have the public document, debug ready, and upstream patch track and the CI instruction. This is the mainline kernel support state. K3 is not just a vendor fork. Before the silicon Pro, we have do the upstream working in the FPGA stage. The model already making this device shaping control GPL clock, and under review USB PCIe. We have our Linux wiki now to talk about the community and open source. For the CI and CD, we will have a real hardware and a real speed. Most RISC V projects still rely on QEMU for CI, which pay the cost in development hours. If you use the real hardware, maybe up to 10 faster than QEMU system mode and 7 faster than user mode. Not just speed, the real hardware expose the emulation heads. We believe K3 will become the native CI backbone for the RISC V ecosystem and open to the OS distribution, the toolchain project, and other community to move beyond the emulation. You can use the K3 platform for the real hardware to develop the RISC V ecosystem. This is different development mode support. For software development, normal have three model development. The first is traditional cross development development model, traditional embedded development model. The tool chain compile on host device. The formula run on the client device. This is ARM development mode because long the early stage ARM's performance is not suitable for compare. The second is the native development mode. This is a traditional PC development mode. The compare and the software run on the same target device. This is a notebook. The development hardware is notebook. This is hardware development SBC. The third development mode is cloud. The new generation development want to access the hardware through web. They maybe not want to add hardware. They want to development everywhere, every time. So we intelligence the hardware into the data center, and the user can through the web to use the hardware. So we name it cloud development mode. So SpacemiT support the cross, the native, and the cloud three type the development mode. Let the RISC V ecosystem and software development more easily and faster than other architecture. For different development use case, we deliver different hardware. This is Pico. Pico just for mainly for the engine computing. This is COM, K3 COM. This is a core module. It is mainly used for the robot computing. And this is intelligence a number of K3 now into a server. Now can use the cloud development and C and CD and development mode. For different use case, we deliver different hardware. This K3 application for AI computing. The first is engine computing, AI workstation, and AI NAS. Different type of the AI computing. The second is AI K3 application for a robot. This is our to customers robot. This name is Tiangong. This name is Linlong. Can running. It's very funny. Because the robot product need very high real-time performance and reliability for the chip, because the robot when running is very, very hot. This is all introduced about RISC V and SpacemiT. Thanks for your time.
So thank you, everybody. Thanks, Yanbang, for your great speech. So this is actually our surprise for today, where SpacemiT is very generous to make donations to RISC V International with their newest K3 board. So maybe we could introduce both of you and we can have a photo session here with your K3s.
Please.
Yes, so maybe Yanbang, you can stand on the left-hand side, and then Andy for RISC V, and you guys can take a photo with your new product.
Okay.
So thank you for the donations, SpacemiT. So here I wanted to also introduce Andy, who's coming from RISC-V International, to talk a little bit about what they're going to be doing with the boards that they're receiving from SpacemiT.
Thank you. Good to be here. I'm Andy. I'm Director of Marketing at RISC-V. So we're really excited about these new K3 boards. As we've been hearing, they're really, the first silicon based on the RVA23 profile, and that's very, very important for us. The RVA23 profile is where we're going to see lots of, the software ecosystem coalesce around. It's going to be, power lots of different applications from Edge AI to, to automotive, to data center, to high performance computing. We've got lots of different working groups working on different applications on RISC-V, and RVA23 profile is hardware is going to be key to that. So again, thank you for your generous donation. It's great to have those boards, and we're going to put them to very good use in the ecosystem. What we're going to be doing is we are going to be making the most of these through our RISC-V Developer Boards program. So the Developer Boards program is here to basically develop the software ecosystem around RISC-V. We're developing a rich software ecosystem is fundamental to what we're doing, and it's fundamental to the success of our members and users worldwide. And through the program, we look to expand the adoption of the upstream open source software within the RISC-V community, and donations like these allow us to seed hardware to the open source software projects for porting to the RISC-V architecture. RISC-V came from an academic background, and research, and academia is key to our success. And one of the reasons, people love to use RISC-V because of its adaptability, its configurability. And so there are lots of research projects using RISC-V, and these boards will also be useful for these things. So just some examples of what we've done using the boards in the developer program. So the firmware and booting standards, the openness BI and U-boot maturity was feedback using actual physical boards dramatically matured the openness BI implementation and U-boot support for RISC-V. UEFI integration directly contributed these boards through the developer program really sped up the maturity of this. And in terms of kernel optimizations, developers around the world have used boards seeded by the developer program to write, test, and manage architecture-specific patches for RISC-V. We also see these boards being used for things like toolchain advancements and excellence, GCC and LLVM. Access to actual hardware has allowed toolchain engineers to validate, benchmark, and optimize code for RISC-V and really improve the support of RISC-V for toolchain. We also have things like Docker and Kubernetes support that's benefited from this, and also V8 Engine and Chromium. Developer boards have allowed our community maintainers to optimize for the RISC-V architecture. So there's lots of great stuff that comes out of of the developer boards program, and this is where we're going to use these K3 boards. So if anybody would like to get involved in the software enablement on RISC-V, please get in touch. We will soon be adding a call to our developer boards page, which is linked at the bottom here. And if you would like to get involved, please do. Please look at the page and submit there. Also, contact Greg Sterling. He's our technical product program manager at RISC-V, who is managing the program. He would love to hear from you if you've got a project that would be that you would like to port to RISC-V. Some of these criteria for selection, not all of them, you don't have to hit all of them, but the things that we take into account are, that it clearly impacts a significant upstream community, that it affects the strategic RISC-V products and markets, so things like physical AI, high performance computing, data center, AI, all these things, we're interested in things that will enable them. Also, we're interested in things that make good use of the capabilities of the SpacemiT K3 platform. So the new capabilities that it enables, being the first silicon available for RVA23, things like hypervisor support are available there. So we're interested in things that really use the capabilities of the K3. And we're, obviously we're really interested in established open source contributors getting a hold of these and making really good use of them. So if anybody's interested, please look at the web page and also contact Greg, and he will be able to help you. Also, if you'd like to hear more about SpacemiT K3, RVA23, and other software enablement on RISC-V, please join us in a couple of weeks' time. We've got the RISC-V Summit Europe happening in Bologna, Italy, so we'd love to see you there. Thank you very much.